What the
What the
heck?
heck is
Happening.
What the heck is happening?
Hallo und herzlich willkommen beim Trending Topics Podcast. Mein Name ist Shemsa Salioski und heute spreche ich mit Sabrina Maniscalco von der BOLD Community. Die BOLD Community, eine Initiative der Wirtschaftskammer Österreich, ist ein globales Netzwerk von visionären Pionierinnen zur Förderung von Innovation und Zusammenarbeit. Durch Begegnungen sogenannter BOLD Minds aus aller Welt entstehen unkonventionelle Ideen und ein reger Wissensaustausch, der Österreich als Innovationshub stärkt. Sabrina Maniscalco ist Professorin für Quanteninformation und Logik an der Universität Helsinki. Sie ist außerdem Mitglied im wissenschaftlichen Beirat mehrerer internationaler Organisationen und ist CEO und Mitbegründerin von Algorithmiq, einem Startup, das sich auf Quantenalgorithmen und Softwares konzentriert. Okay, now I will switch to English. Sabrina, thank you very much for being in our podcast. Shall we start with the first question?
Yes, thank you very much for having me. I'm looking forward to this conversation.
It's a pleasure. Well, many of us watched Oppenheimer, where lots of quantum related, let me put it that way, terms were mentioned. Now I have the pleasure of speaking to you, one of the leading experts in that field. Therefore, my first question would be, what does quantum technology actually mean, since many of our listeners are non-experts?
Yes, quantum technologies are technologies that are based on quantum physics. So, quantum physics is a branch of physics that deals with the behavior of microscopic particles that are really the basic ingredients, the basic constituents of our universe. So, it's a very fundamental physical theory explaining really the laws of nature and how our universe behaves. At a very deep level and microscopic level. And well, it has been, of course, one of the major revolutions in history of sciences and physics, but only very recently, well, maybe 50 years, 20 years, we started to learn how to build new technologies using the laws of quantum mechanics. So this is much more recent with respect to the history of quantum physics. You mentioned, of course, Oppenheimer, the movie. So quantum technologies are a second, we often refer to them as the second quantum revolution, because it's really the moment in which we go from something which is really more of a abstract theoretical science to something which becomes more in a way useful to create new technologies with the potential to revolutionize our society. And examples of these technologies are quantum computers, quantum communication devices, and so on and so forth. When we talk about this second quantum revolution with respect to the previous one, is because we aim at really exploiting properties such as entanglement or superpositions that are very in some sense paradoxical. I use sometimes this term, but it is not always appropriate, because there is nothing magic in these properties. It's just in a way a bizarre way in which nature behaves that is always surprising us.
Mm-hmm. So now let's talk a little bit more about you. What first drew you to quantum science in general? And can you tell us a little bit more about your academic career, maybe what projects you're most proud of, or whatever you want to tell us?
Yes, with pleasure. So the choice of studying quantum physics was really something that dates back to I think I was 16 or 17, and it started with the fact that I loved, I had a small telescope, and I loved spending evenings and nights by exploring the starry sky. So I started to read more about, these black holes and stars formations and the universe. And I became really passionate about first astronomy and then astrophysics. And as I started to, when I had to decide how to study or what to study for the university, I wanted to study astrophysics. But then, I started my career as a physics student. But then the first course in quantum physics was really what changed my plans because I fell in love really with quantum physics, and in particular with the beauty of quantum physics and the beauty of the laws of nature. It's very fascinating for me. And I always loved math. Math is a interesting language, different from what we are used to speak. It's less universal, but it is a language. So if you had a good teacher at school, and if you are in a way eager to play with this language, then it's fantastic to use it to discover more about our universe and really the beauty of nature.
And well, besides your impressive academic career, you're also the co-founder and CEO of Algorithmiq. Am I pronouncing it right?
That's correct.
Algorithmiq.
Yes, that
All right. And that is a startup focusing on quantum algorithms and software. Can you tell us some details about the founding story?
Yes, yes. As you mentioned, I am a professor of quantum information and computing at the University of Helsinki, and before moving to the University of Helsinki, I'm talking about 2020. So it was really in the middle of the pandemic. I was a professor in the University of Turku, that is another city, the previous capital of Finland, actually. And at that time, I had a very talented team of researchers working with me, and we started to be more engaged with quantum computers, in the sense that we started to join some of the sort of unconferences. Actually, they were camps or hackathons of very early developers of IBM quantum computers. So they were organized by IBM at that time, and we started to realize that actually we had discovered some essential ingredients of what could be really the key to the door of useful quantum computation. So to program actually these quantum computers. So what happened is that we, at that time, just by chance, we met a business, what was our business co-founder, the person who came from business, because my background was in academia, who completely believed in us, and he said, well, this is the right time. Would you like to start up a company? As I said, it was the beginning. I would say it's the combination of really having the right people in the right moment of time. And I was, as I said, moving from one university to another. So many things were happening, and also from one city to another, many things were happening. And I always loved challenging myself. I wanted to do something new, different. I wanted to add new experiences to my academic career, and it's been an amazing experience. I loved it, and I still am particularly enthusiastic. And I would say that one of the most exciting things is really the fact that I believe that we are really at the edge of really something which will change profoundly our society. And to be the very first, the early developer of this technological breakthrough is particularly exciting, because we see very quick, profound changes, and how the technology is really developing quickly to become really at a level of maturity where will impact applications at large scale. So this is I feel very lucky actually to be at this specific point in history.
I can tell you're very passionate about it, and I think it's beautiful.
Thank you.
Before our conversation, I was exploring the website, and on the website, the following is stated. We envision a world in which new drugs can be discovered and invented quickly, efficiently, and cost effectively, leading to affordable and precise medical treatments. Now, my question is, why did you choose to focus on medical treatments?
Yes, that's a very good question, of course. So it's a combination of two factors. One is the fact that we had to explore what are the applications of quantum computing that are closer to be developed given the very early stage of our technologies. And we do know that one of the most promising applications is modelization or simulation of what we call, I will use a technical term and then I will explain it. It's called electronic structure problems. What does it mean? It means to simulate on a quantum computer, so to mimic, if you want, on a quantum computer, molecules that are used as drugs. And this is considered as one of the early and most powerful and disruptive applications. So once we understood that this was actually what could be done already at the early phases, then we thought, okay, obviously this is still a wide range opens a wide range of possibilities, because it could be done, for example, for designing new materials, it could be done for designing new type of fertilizers, or it could be applied to the life sciences. And we thought that our call was more for the life sciences, because if we think in terms of drug discovery and development, this is an industry which is really facing a serious R&D challenge. So at the moment, we know that despite the increase in spending in discovery of new drugs, the number of new drugs or new molecular entities that are brought to market remains the same. So there is something which needs to be done differently. And we think that the power of quantum computer is what is needed to unlock this change. And so the combination of these two factors, the applications of early stage of quantum computers and the need to solve an R&D challenge, which is very important for society at large.
On the website, I also read that AI plays a role. Can you tell us a little bit more about that? How are you using AI?
Yes, so we are not only us, actually, I would say in general, the early stage of quantum computers, so the applications of quantum computers as they are now, they are not to be considered as, alternatives to existing conventional computational methods like AI or machine learning. So they are not opposed to AI, but they are actually complementing them. So they're complementing each other. We use the term hybrid. They are hybrid methods, hybrid techniques. This means basically that part of the software that we develop contains traditional or conventional AI methods, not only algorithms that are run on a quantum computer. So we use both. At the same time, there are some limitations of AI that can be bypassed by quantum computers. So, for example, there exist methods that require large training data sets with AI that could be instead so this need of extensive training data sets can be bypassed by ab initio simulations with quantum computers. So it's just to say they are different, they complement each other, but there will be some advantages that are uniquely related to the use of quantum computers.
Okay. And I mean, I know it's a startup, so everything is in a very like pre-stage maybe, but has Algorithmiq already achieved the wanted first positive results? Or if not, how long do you estimate will it take?
Yes. So definitely, we have already achieved what we think is the first milestone, or actually a series of milestones. Before raising Series A, our major milestone was the two major milestones were, first of all, a software platform that would allow us to provide algorithms for quantum chemistry simulations that scale, meaning that they allow to grow or to tackle problems of increasing complexity. And now our platform, Aurora, is available commercially for partners. So this is a major milestone. We launched it last autumn, and now we are continuing, of course, to develop it in different directions, but it is already available. And then the second important milestones pre-Series A was the hardware partnerships, because we are a software company and we need to obviously partner with the major quantum computing hardware providers, in our case IBM. And this is again another milestone that we have achieved. And now the new important milestone is to, of course, apply our algorithms and discovery to life sciences. And for this, we have recently been awarded multi-million program by Wellcome Leap, and this is something that we are starting to already from the 1st of September for the development specifically of photoactivated drugs. So this is specifically for cancer treatment and simulation of photoactivated drugs on quantum computers with two very high-level partners that I cannot yet disclose. But again, this is a major milestone because it is something that will allow us really to apply our discoveries to the field of life sciences and specifically to cancer treatment.
Okay. And I mean, one rather general question: how do you think, if you can answer it, how do you think the next 5 years in that whole field will look like? Will we see more of it?
Yes, of course, it's important that you say it, if you can answer, because obviously here we are really more at the level of speculation, because the field is evolving so
For
quickly.
sure, yeah.
So it's really difficult to foresee what will be in 5 years. But I can say that based on our proprietary platform and algorithms, and based on the knowledge we have now on what we can do with quantum computers, I think that the first milestone or the first major disruptive change that I can foresee within the next 5 years will be the achievement of quantum advantage for industrially relevant use cases. What does it mean? It means the demonstration that quantum computers are superior to any classical computer for something that is industrially relevant. And I think that this will be happening in the framework of the next 5 years. This will obviously be changing the world at large.
Mm-hmm. Well, since we're also currently speaking within the context of the BOLD community, I also have a few questions on that. What exactly made you join the BOLD community?
Well, it's interesting because I was attending Slash last year. I was a speaker at Slash. It is one of these big events for startups held in Helsinki every year. And I met there, now I don't remember the name, but I met there someone from the BOLD community. And we chatted very briefly. I remember she gave us some nice BOLD, it's like a bracelet or something. And I was very intrigued because I really liked it, and I liked the idea of I like bold as a name, as a noun. Bold is and the concept that is behind bold, what it means to be bold, and it made me think: in which sense am I bold? How much or in which way I would like to be more bold? And then this brought me closer to the bold community. And when I received the invite to join the community and to join the conference, I'm very much looking forward to. I was very excited. I had no doubts. I was really in a moment in which I was really declining and actually canceling my attendance to very many events because I've been after raising successfully Series A, I really had a period of I would say burnout. Honestly, I have to say it. It was a real burnout, and so I decided. I mean, I really need to go back to myself and decide what do I want to focus on.
Mhm.
And so I started to, I decided I had to say no much more than what I was used to before.
Mhm.
This was one of the opportunity I really did not want to miss. And so I'm very much looking forward. And I like the concept, I like the idea, and I like the community.
Mhm. And how exactly can people work with you via Bold?
Well, I think most than anything, in my work and in my personal development, I really appreciate multidisciplinarity and discussions that can seem, in a way happening just by chance, but there is something behind. I call it engineering synchronicity. So it's a way of providing occasion for people that are really looking for this growth and also for create an impactful change in our society to come together and to exchange experiences in a context or in a framework or in an environment which is beautiful in some sense. Beauty can be due to nature, it can be related to many things. But I think that these occasions, and this is also has been my experience in the past, every time I look back, I see that the key moments in my career, in my life, happened in this during these occasions. They seem like random encounters, but they are not, because they are if you want, on the one hand, due to the fact that you open up to people with completely different background and completely different experiences, you truly listen. And on the other hand, very often there is someone who is carefully creating opportunities for these encounters to happen.
Mhm.
So yes, this is I'm what I'm looking for is just truly exchange of experiences, life, project, crazy endeavors, all of it.
Mhm. Thank you. Two final questions. I mean, you kind of mentioned it before, but can you recall a moment in your life? I don't want to say career, just in your life where you had to be bold.
Yes, so I think I can think of more than one, but maybe some of them I wouldn't say publicly. But I would say that certainly, okay, one related that I already mentioned is related to the choice of actually co-founded a company, a startup, while having already a successful academic career, because this was a big shift in my life.
Sure.
I
Yeah.
had to start doing something. I wasn't, so being CEO is not something I've been trained for. I'm constantly learning, but it meant to really challenge myself to do something completely new, and I think we always have to take risks. If we live a too comfortable life, we don't go anywhere, right? So I think that actually the true meaning for me of a life well lived is really to push myself out of my comfort zone and experience things that I profoundly think are calling me, but that require also, um, to take a risk. And so, in this sense, I am bold, and I like to be even bolder.
I love this. Okay, the final question. Is there anything you would tell younger people that are interested in a similar career?
Yes, I think, of course, some time ago or in a couple of maybe years ago, I would talk about how you need to be passionate about what you are doing, and I've always been repeating this being passionate about what you are doing, because it's a very hard, and you have to do a lot of sacrifices, work a lot, study a lot, and sacrifice many things. And if you don't truly love it, or if you don't have passion for it, it's a nightmare, honestly. But actually, I don't know if maybe passion is not the only and not necessarily the right word for everyone. So there are people who don't know what is their passion. I think what is important is to have a mindset that is open to exploration and curiosity. So I think that if you want to explore quantum physics and the career as a scientist, and you just keep being curious about it and finding your own way of learning it, which is not necessarily needs to be the logic way. There are many ways of exploring and playing with quantum physics that are preliminary really to the mathematical and logical thinking. Although if you want to become a professional, you will obviously need to like also math. There is no way around. But find your own way and be curious about it. And if you think that you are enjoying spending your time, you enter into this flow state, and you want to do more of it, then it's your call. And it won't be easy, but it is fascinating, and I think it will be a very strong part of our future and society.
Thank you so, so much.
Thank you.
So, jetzt sind wir auch schon am Ende der heutigen Folge. Danke fürs Zuhören und bis zum nächsten Mal.